All right, guys. So, welcome to today's tutorial. All right, thanks for joining us. So, we'll go into the tutorial straight away. Now, today we are going to be looking at differential equations, linear equations using integrating factor. So, if you recall that we did something that has to do with, we have done separating variables. We have done equation separable. So today we are going to be doing we are going to be looking at linear equation. So anytime you are solving differential equation and it's in this form, that's dy dx. Okay, so let's call it differential equations, and we're going to be looking at linear equation. Okay. All right, this is what we are going to be looking at. That's terrible. That's terrible. So, okay, linear equation. So, anytime you're solving a differential equation and you have it in this form, that if you have it like dy dx plus py equals q. Okay, so anytime you are solving an equation and it's in this form like this, then you should know that this is a linear equation, and you have method for solving it. Okay, and how do you do that? First of all, you need to find something called the integrating factor. I call it if. So let me say integrating factor. We call it integrating integrating factor. Integrating factor. Okay. Then integrating factor is equals to e raised to the power of integral of p dx. So this one is the formula for calculating integrating factor. Please don't forget. And so basically that is what you need in order for you to be able to solve any differential equation. Then finally, after you're getting your integrating factor, then for you to finally solve it, you just say that y multiplied by integrating factor is equals to integral of q multiplied by integrating factor dx. So this is now the solution for what? For the differential equation. So don't forget that the differential equation is all about you trying to eliminate the derivative and trying to find a relationship between the x and y. So, and I told you that there are different methods you can use. So we have looked at the two of these methods. So this is the third method we'll be looking at. All right, let's take an example so that you'll be able to understand what I'm trying to say. The first example we are going to look at is, let's say that you have x dy dx plus y, which is equals to x raised to the power of 3. Okay, the first thing is that you try to make this example to be in this form, dy dx plus py, which is equals to q. So you make it come in this form. So if this equation can come in this form, then it's very easy for you to do. All right, let's go again. Now, once we have that x dy dx plus py equals rather plus y plus y equals to x cube, right? So now for us to make this equation to look like this, what do we need to do? Okay, what we need to do is that we'll divide both sides by x. So it's going to be x dy dx plus y, which is equals to x cube. So we divide this one by x, we divide this one by x, we divide this one by x. So this x will cancel this x. This x will remove one of this x. This will become x squared. Then we can have dy dx, which is equals to y over x, which is equals to x squared. All right. Now that we have the y dx plus 1 over x into y, which is equals to x squared. So here we need to get p. So p will now be 1 over x and q will now be x squared. Okay, so from here we can solve our integrating factor. So we simply say that integrating factor is equal to, that is, what is the integrating factor? Is going to be e raised to the power of p dx. Now, e integral of what is p? P is 1 over x dx. Then e raised to the power of integration of 1 over x is the same as ln x. Okay, and anytime e is raised to the power of logarithm of anything, then it becomes that thing. So e raised to the power of ln x is the same as x. So that's it. All right, so we have gotten our integrating factor. Then we now use our formula. The formula is y multiplied by integrating factor, which is equals to integral of q multiplied by integrating factor dx. Okay, then let's apply this formula. We are going to have, that was y. Okay, we know y. Then if is x. That's what we have here, integrating factor. As you can see, these are integrating factor here, which is x. Then let's move on, which is equals to integral of what's q? Q is x squared. You can see from here, these are q, x squared. So it's going to be x squared multiplied by if. If is also x multiplied by dx. All right, so we have that y is equals to integral of x squared times x will give you x cubed dx. Then let's integrate. Xy is equals to integration of x cubed is x raised to the power of 4 over 4 plus c, isn't it? So you can leave the answer like this, or you just divide both sides by x. So therefore your y will now be x raised to the power of 3 over 4 plus c raised to the power of x. So whichever one is correct. All right, so that is, it's as simple as, I hope you understand. I hope you're getting this thing. It's very easy. Okay, let's take another example. Let's say that you have dy dx plus y cot x, which is equals to cos x. Okay, if you check this now, you notice that this one is already in the form of linear equation. That is, our linear equation is dy dx plus py, which is equals to x, which is equals to q rather. So you notice this one is your p and this one is your q. So what do? You just go straight into it. So p is equals to cot x and q is equals to cos x. All right, so let's look for, the next thing is you look for integrating factor. So integrating factor is going to be e raised to the power of integral of p dx. Now, e raised to the power of integral, what is p? P is cot x rather, not cot x. All right, so let me put cot x dx. Then what is the integration of cot x? So let's really look at what is this cot x before we can integrate it. Integral of cot x is the same as cos x divided by sine x. Yeah, that's the meaning of cot x. So you notice that if you differentiate the sign, you get cos. So therefore, we'll say that integration of cot x is equals to ln sine x. All right. I already told you that anytime e is raising to the power of the natural logarithm, which is ln of anything, it becomes that thing. So this is going to be your answer. So sin x is our integrating factor. Then we'll use our formula, which is y multiplied by x is equals to integral of q multiplied by if multiplied by dx. So which is going to be, sorry, not x, integrating factor rather, if. So we are going to have that. What is our y? Y is x? No, that's wrong. Okay, so we have our y dot, what is if? If is sine x, which is equals to integral of, what is q? Q, already have q here, you can see q. Our q is cos x, so we use it. So q is going to be cos x multiplied by, then if is also sine x multiplied by dx. All right, now if you check this type of integration, this is called integration by substitution. So if you want to solve this type of integration, you are going to use integration by substitution. So you can check some of my video, integration by substitution. So you can check some of my videos. So I'm going to put the link in the description below. So if you want to really study integration by substitution, the video will really help you. So but let's continue. So if you have y multiplied by sine x, which is equals to integral of cos x multiplied by sine x dx, how do you do? The first thing you say let u be equals to sine x, then you differentiate. So du dx will be equals to cos x, right? Then you make dx subject of formula. So your dx will now be du divided by cos x. Okay, so after you've done that, you now say y sine x is equals to integral of cos x. So don't forget that you already say u is equals to sine x. So in this place, you are going to put u, multiply by u, then multiply by your dx now. According to this one, your dx is du cos x. So this cos x will remove this cos x. Then you have integral of, which is equals to integral of u du. Now when you integrate u, already know is going to be u squared over 2, then plus c. Therefore, y multiplied by sine x is equals to u. What is u? U is sine x, so it's going to be sine x squared over 2, then plus c. Then you have that y multiplied by sine x is equals to sine square x over 2, then plus c. Then you can divide both sides by sine x to have that y equals to sine x over 2, then plus c divided by sine x. So that is your answer. All right, that's good. Let's take another example. So let's say that we have um, x plus 1 dy dx, then plus y, then which is equals to x plus 1 squared, isn't it? All right. We compare it with the normal form, which is the y dx plus by, which is equals to q. Okay, then so if you compare, you discover that this this is not, something is wrong, so you need to remove this one, right? So let's remove it. In order for us to remove it, you have to divide by x plus 1. So if you divide by x plus 1, we'll have that x plus 1 dy dx plus y is equals to x plus 1 squared. So we divide by x plus 1, we divide by x plus 1, we divide by x plus 1. So this, we remove this. Then we have that dy dx plus y over x plus 1 is equals to x plus 1 squared divided by x plus 1. All right. They will now have that dy dx plus, so we can put this on in bracket to be 1 over x plus 1 multiplied by y, which is equals to x plus 1 squared over x plus 1. So this will remove one of these. You'll be left with x plus 1. All right, so from here now, we can get that our dy dx plus 1 over x plus 1 multiplied by y is equals to x plus 1. Therefore, p will be equals to 1 over x plus 1 and q will be equals to x plus 1. Then integrating factor if will be equals to e raised to the power of integral of p dx. And what is p? P is 1 over x plus 1 dx. Then integrating factor will be equal to e raised to the power of, if you differentiate this one, is going to be ln x plus 1. Okay, and once you have something like this, then this is going to be your answer. Then the integrated factor is going to be x plus 1. All right, then we apply our formula. The formula is y multiplied by integrating factor, which is equal to integral of q multiplied by integrating factor. So q multiplied by the integrating factor dx, then which gives us that y multiplied by, what is the integrating factor? X plus 1, which is equals to integral of, what is q? Q is x plus 1 also, and the if is also x plus 1 also, then dx, right? So we have that x, oh sorry, we have that, so we have that y multiplied by x plus 1 is equals to integral of x plus 1 all squared, all squared. So we are going to square it, then you put your dx. All right, the same way we are going to use integration by substitution. So that's what we are going to use here. So for integration by substitution, we say let u be equals to x plus 1. Therefore, du dx will be equals to, when you integrate u, which is equals to x plus 1. So if you integrate u, it's going to give you 1, because integration of x is 1 and differentiation of x is 1 and differentiation of 1 is 0. So you differentiating x plus 1 to give you 1. So therefore you make the x as formula, then the x will now be equals to du. All right, Jumoke, thanks for joining us. Okay, then we have y into x plus 1, which is equal to, let's see, so we have integral of, you already said this is u, so it's going to be u squared multiplied by your dx is now du. So which is going to be, when you integrate u squared, it's going to be u raised to the power of 3 over 3 plus c, right? Therefore, let's move it up a little. Then I have y into x plus 1, which is equals to u. U is what? X plus 1 cube over 3, then plus c. You can leave your answer like this, or you can say y you divide both sides by x plus 1. So your y can now be x plus 1 squared over 3, then plus c over x plus 1. All right, so that is the answer. I hope you all are getting me. I hope you understand what I'm doing. Okay, so let's move to the next question. So all right, let's say that you have x dy dx. So x dy dx minus 5y, which is equals to x raised to the power of 7. Okay, the first thing is that you have to make it look like this. So anytime you are given any type of linear differential equation that has to do with linear, Okay, Jumoke, are you getting me? All right, that has to do with linear. Then you can simply say that. Okay, so you can simply say that. So you divide both side by x. Let's divide both side by x. Let's divide both side by x. So we're going to have that dy dx minus, that is 5 over x y, then which is equals to x raised to the power of 6. Okay, x raised to the power of 6. All right. All right, let's go. Now, here you can get your p. Your p will be minus 5 over x, and your q will be x raised to the power of 6. Then let's look for integrating factor. Integrating factor is going to be e raised to the power of integral of p dx. Right, that will be the integrating factor. Then which is equals to e integral of, what is p? P is minus 5 over x dx. Then the integrating factor will be equal to e raised to the power of, you take out the minus, then you take out the 5. You are going to have integral of 1 over x dx. So on integration, you know that this is going to be minus 5 ln what? Ln x, right? Yes, it's going to be minus 5 ln x, and you are going to have e raised to the power of ln x raised to the power of minus 5, because this we have to come like this according to the law of logarithm. Then finally, your integrating factor is going to be x raised to the power of minus 5, and which is the same as 1 over x raised to the power of 5. All right, then let's use our formula. So the formula is going to be, y multiplied by, multiplied by so it's going to be y multiplied by if, which is going to be q dot the if dx. All right, dx. Then y dot, what is if? That's 1 over x raised to the power of 5, which is going to be q is going to be x raised to the power of 6 multiplied by 1 over x raised to the power of 5 dx. Then which will give you y equals to, sorry, multiplied by, rather, multiply by 1 over x raised to the power of 5, then which is equals to integral of x raised to the power of 6 over x raised to the power of 5 dx. So you notice this will remove this, it will become x. So we have integral of x dx. Therefore, y over x raised to the power of 5 is equals to, when you integrate that, is going to be x raised to the power of 2 over 2, then plus c. Okay, you can leave your answer like this, or you decide to cross multiply. Then you have y equals to uh, x raised to the power of 7 over 2 plus c. We cross multiply, then you have c raised to the power of x raised to the power of 5. So this is your answer. Y equals to x raised to the power of 7 over 2 plus c x raised to the power of 5. All right. Okay, let's take another example. This is a trigonometric example. Now let's say that you have, tan x dy dx, then plus y, which is equals to sec x. Okay. All right. First thing, we have to make it look like this. Dy dx plus py, which is equals to q. So we have to make it look like this. Now, how do we do that? We have to divide both sides by this tan x. So it's going to be tan x dy dx then plus y over tan x, which is equals to sec x over tan x. Okay, and this is also divided by tan x too. So this, we remove this. Then we are going to have dy dx then plus 1 over tan x multiplied by, or we can put it in brackets, multiplied by y, which is equals to sec x divided by tan x. Okay, let's go. Now from here we discover that p is equals to 1 over tan x, right? Which is still the same as 1 over tan x is still the same as cot x. 1 over tan x is the same as cot x, right? Good. It's the same as cot x. Then q is equals to sec x over tan x. Then let's look for integrating factor. So integrating factor will be equals to e raised to the power of integral of cot x dx, right? Then which is going to be e raised to the power of cot x. I already told you that cot x is the same as cos x over sine x dx, isn't it? So integrating factor now will now be e raised to the power of, if you integrate this, it's going to be ln sine x, then which is going to be this as your answer, that is sine x. All right, we'll come here and say that y dot integrating factor, y dot integrating factor is equals to integral of q multiplied by if dot dx, then y multiplied by integrating factor is sine x, which is equals to integral of q is, okay, from here, what's q? Okay, q is sec, so q is sec x over tan x multiplied by integrating factor is sine x, then multiplied by dx. So we need to break this down. We need to break it down. First of all, sec x multiplied by 1 over, look at the way I want to break it down, and then multiply by sine x, then dx. Okay, let's break it down again. Then we now have that y multiplied by sine x is equals to integral of, now this is going to be sec x multiplied by, now 1 over tan x is cot x and is the same as cos x over sine x multiplied by sine x dx, right? Okay, let's further break it down. Sec x is the same as 1 over cos x multiplied by cos x over sine x multiplied by sine x over 1, then you have your dx. So this will remove this will remove this. So we have that y multiplied by sine x is equals to integral of dx. All right, integral of dx, then we have that y multiplied by sine x is equals to, when you integrate dx is x, then plus c. So what do you do? You can leave your answer like this. You can leave your answer as y sine x, or you can say x, or you can simply say y is equals to x plus c over sine x, or you can say sine inverse of x into x plus c. So anyone, whichever way is correct. Okay. All right, let's see if we can. Okay, let's solve this. Let's solve this. let's solve this example. Finally, let's solve this example. Let's say that you have x dy dx. I hope this thing is getting clearer. It's very simple. Plus y, which is equals to x sine x. All right, so we have to make it look like this: dy dx plus py, which is equals to q. Okay, then how do we do that? We have to divide by x. We have to divide by this one to make it look like that, which is equals to x sine x. So let's divide this one by x, divide this one by x. So this will remove this, and you notice this can also cancel this. So therefore, you are going to have that dy dx plus y over x is equals to sine x. From here, you now have that dy dx plus 1 over x into y, which is equals to sine x, right? So what can we deduce from here? P is equals to 1 over x and q is equals to sine x. Then we can simply say that integrating factor is equals to e raised to the power of p dx, which is equals to e raised to the power of, what is p? P is 1 over x dx, then which is going to be e raised to the power of, that's ln x. If you integrate, is going to be ln x. Then your answer is going to be x. Okay. Then so which means your if is equals to x, that's the integrating factor. Then we'll now say that y dot integrating factor, which is equals to integral of q dot integrating factor multiplied by the x, and you have that y multiplied by integrating factor is x, then integral of q, our q is sine x, then if is also x, then you have dx. Wow. Okay, so we are here. Okay, all right. um okay, okay. So right, let's go into it. Then we have that x y equals to, now this is so where we are now, this is, so in order for you to solve this, you have to use integration by parts. So in order for you to solve, you have to use integration by parts. Okay, so for some of you that don't understand integration by parts, okay, I'll just do a quick review on integration by part and how it works. Our time is almost done. Up. Now, integration by part is uh, u dv, integral of u dv is equals to uv minus integral of v du. Okay, so we are using this pattern. Uh, Okay, you can see this is logarithmic function, this is inverse function, this is algebraic function, this is trigonometric function, this is exponential function. So this is algebraic function and this is trigonometry. So algebra is come before trigonometry. So we say that u is equals to x and t rather. So then we say that dv is equals to sine x dx. So you differentiate this, you integrate this. So let's do that. So if you differentiate, it's going to be du dx. If you differentiate x, you have 1. And if you integrate this, you have your v will be equals to minus cos x. That's if you integrate this, you have minus cos x. Okay, so let's put it back into that formula. So the formula is integral of u, that's integral of sine x dx is equals to, what is u? U is x. What is v? V is minus cos x, then minus integral of, what is v? V is minus cos x, and what is du? So your du from here, du will be equals to dx, that's if you cross multiply. So du is dx. Okay, so which is going to be minus x cos x. That's when you multiply this, then minus times minus will give you plus, then integral of cos x dx, then minus x cos x plus the integration of cos x is sine x. That's the integration of cos x is sine x. So therefore, once you integrate x sine x dx, then the answer is minus x cos x plus sine x. That's all you have. So let's put it back into what we are doing. So we have that xy is equals to integral of x sine x. That's what we are solving. And when we find the integration of this one, our answer is minus x cos x plus sine x. Then you put your c. So therefore, xy is equals to minus x cos x plus sine x plus c. Okay, you can leave the answer like this, or you can say that y is equals to, if you divide both sides by x, is going to be minus cos x, then plus sine x over x, then plus c over x. So that is your answer. All right, guys, thank you so much for joining today. Okay, tomorrow we're going to be looking at another wonderful topic in mathematics. Thank you so much. Make sure you like the video, make sure you share it, make sure you comment. You can ask questions. If you don't understand, I'll be very much happy to answer you. And in case you feel there's something wrong with it, you can also comment too. You're welcome. And don't forget to subscribe. Thank you.